Welcome to the deep dive. Today we're going to be looking at something pretty fundamental,
Right.
linear equations, but
Right.
with two variables this time. So
Yeah.
we're kind of leveling up a little bit from,
Yeah, that's great.
the basic equations that we've dealt with in the past.
Building on what we know.
Exactly.
Yeah.
So I guess a good way to think about this is, any situation where you've got sort of two unknowns,
Yeah.
right?
Two pieces of information that you're trying to figure out.
Yeah, exactly. Like, let's say you're watching a cricket match,
Okay.
and two batsmen together
Yeah.
score 176 runs.
Right.
So,
Yeah.
how could you represent that mathematically?
So we could say, let's say X is the run scored by the first batsman,
Okay.
and Y is the run scored by the second batsman.
Okay.
Then X plus Y
Oh.
equals 176.
Got it.
And so there you have it, two unknowns
Yeah.
captured in one nice, neat equation.
Yeah, okay.
Now, in the past, we've looked at equations with just one unknown.
Right.
Like X plus 1 equals 0.
Exactly, yeah, and those
Yeah,
are.
you're going to, X has to be -1.
Right.
There's no other.
There's only one solution.
Yeah, there's only one solution, exactly. But now that we're adding in a second variable,
Yeah.
It really sort of opens up a whole another can of worms.
It really does.
In terms of like, how do we even
approach this?
Yeah, does a solution even exist?
Right. Yeah, does a solution even exist? Is there only one?
Is there only one? Or are there many?
Could there be many?
Could there be many?
Absolutely.
And then how do you even...
And then how do we visualize?
Yeah.
What does the solution even look like?
Right, yeah.
So we're kind of entering a whole new...
Yeah, we're entering uncharted territory.
Uncharted territory here.
Right.
So that's what we're going to be looking at in this deep dive.
Okay.
And we've had some really great material to kind of dig through.
Yeah, we've got some great resources to guide us on this journey.
So I guess let's just jump right into it. What formally is a linear equation with two variables?
Okay, so the textbook definition says that it's any equation that can be rearranged into the form x plus b plus c equals 0.
Okay.
Where a, b, and c are just real numbers.
Okay.
But importantly,
yeah,
a and b can't both be 0 at the same time.
Okay, so one of them can be 0.
One of them can be 0, but not both.
Right.
Yeah.
Okay, and to make this more concrete, we've got some examples in our sources here.
Right. So some examples that we can look at. 1.2s plus 3t equals 5.
Okay.
Or p plus 4q equals 7.
Okay.
Or even pi u plus 5v equals 9.
Okay.
And then one that looks a little different at first glance.
Okay.
3 equals 2x minus 7y.
Hey, so how do all of these fit into that?
Yeah, how do those...
Max plus b plus c equals 0.
Fit that mold? Well, let's look at the first one. 1.2s plus 3t equals 5.
Okay.
You can rearrange that to be 1.2s plus 3t minus 5 equals 0.
Right.
Right. And so you can see the a is 1.2, the b is 3, and the c is -5.
Okay.
And then that last one that we look at, 3 equals 2x minus 7y.
Right.
That can be rearranged to be 2x minus 7y minus 3 equals 0.
Okay.
So the a is 2, the b is -7, and the c is -3.
Okay, got it.
So they all fit that same pattern.
Right, cool.
Now here's kind of a slightly different angle on this.
Okay.
What about equations that just have an x term and a constant?
Oh.
So x plus b equals 0.
Okay.
Now, are those still considered
Right.
linear equations in two variables?
That seems like a bit of a trick question.
It does, doesn't it?
Yeah.
Because how can something that only has x in it be in two variables?
Right.
Well, the way to think about it is that equation is really mathematically the same as x plus 0, y plus b equals 0.
Oh, okay.
So the y term is still there.
I see.
It's just that its coefficient is 0.
Right.
And so for all intents and purposes, it still fits the definition to a linear equation. It's two variables.
Okay, that makes sense.
Right.
Yeah, that makes sense.
So if we had, for example, 4 minus 3x equals 0,
right.
That's really -3x plus 0, y plus 4 equals 0.
Okay.
So it's just sort of a sneaky way.
Yeah.
It's embodying it.
Yeah, a hidden eye.
Got it.
So,
and it follows then that like even simple equations like x equals -5.
Yeah, x equals -5 can be written as...
It can also be viewed in this two variable, can be written as 1x plus 0y equals -5.
Yeah.
Similarly, y equals 2
Right.
is the same as 0x plus 1y equals 2.
Got it. Got it.
And even something like 2x equals 3
Yeah.
can be rewritten as 2x plus 0y minus 3 equals 0.
Right.
And 5y equals 2
Yeah.
is the same as 0x plus 5y minus 2 equals 0.
Okay.
It's just about recognizing the underlying structure
Got it.
of these equations.
Cool. So you've got a good handle on like what these equations look like.
Yeah, we've got...
Now let's talk about what makes a pair of numbers a solution
Okay, good.
to one of these equations.
So a solution to a linear equation in two variables is simply a pair of values.
Right.
One for x
Okay.
and one for y.
Okay.
That when plugged into the equation, make the equation true.
Right. Okay.
And we write this solution as an ordered pair.
Ordered pair.
X, Y.
Okay.
And the order is important.
Okay.
So as we'll see.
Got it.
So the material uses the example 2x plus 3y equals 12 to kind of illustrate this.
Right.
They show that 3-char is a solution.
Okay.
Because 2 times 3 plus 3 times 2 equals 12.
Right.
0, 4 is also a solution.
Okay.
Because 2 times 0 plus 3 times 4 is also 12.
Right.
But 1, 4 is not a solution.
Right.
Because 2 times 1 plus 3 times 4
does not equal 12.
is 14, not 12.
Right.
Right.
Got it. And so the order matters there.
And the order matters there.
Because you said 0, 4 works.
Yeah.
But if you swapped it.
If you swapped it and made it 4, then 2 times 4 plus 3 times 0 is 8, not 12.
Yeah, okay.
So 4, 0 is not a solution for that particular equation.
All right. So how many of these solutions?
Yeah, how many of these solutions?
What are you talking about for a single linear equation in two variables?
Is it just a couple?
Is it just a handful?
Yeah. Or is it something else entirely?
Something crazy.
And this is where it gets really interesting.
Okay.
A linear equation in two variables actually has infinitely many solutions.
Whoa, infinite.
Infinite.
That's a lot.
A huge number.
That's how can that be?
Well, let's think back to that example.
Okay.
2x plus 3y equals 12.
Okay.
The material shows that if you pick any value for x.
Okay.
Let's just say, for example, x equals 2.
All right.
You can plug that into the equation and solve for y.
Right.
And in this case, you would get y equals 83.
Okay.
So 283 would be a solution.
Right.
And they also try x equals -5.
Right.
And if you plug that in and solve for y, you get y equals 223.
Okay.
So that 223 is another solution.
Right.
And so
you're saying you can just keep picking numbers for x.
Picking numbers for x.
Yeah.
And there will always be a corresponding y.
That will make the equation true.
That makes the equation work.
Got it. Got it.
Yeah. And so conceptually what this means is that there's this kind of continuous relationship between x and y that's defined by this equation.
Got it. Got it. Okay, cool.
All right, so
let's get into some
let's get into some more practice.
More concrete examples.
With finding these solutions.
So example 3 in our material says find 4 different solutions for the equation.
Right.
X plus 2y equals 6.
All right. So
what are some of the quotients here?
Well, one way to do it is just to try out some values.
Okay.
You might notice that if x is 2 and y is 2, then 2 plus 2 times 2 is 6.
Okay.
Right. So 2 is one solution.
Okay, that's one.
Yeah, that's one.
Now, how did they find the other 3?
Well, another way to do it is to systematically set one of the variables to 0.
Oh, okay.
So if we set x to 0, then we get 2y equals 6.
Okay.
So y equals 3.
Right.
So 0, 3 is another solution.
Okay, and then the other way around, if you plugged in 0 for y.
Exactly. If you plug in 0 for y, then you get x equals 6.
Right.
So 6 is another solution.
Got it. Okay. And then they needed 4.
Yeah, and they needed 4. So
how did they find the last one?
So for the last one, they just chose another simple value for one of the variables.
Yeah.
So if you let y equal 1, then x plus 2 times 1 equals 6.
Right.
Which means x plus 2 equals 6.
Right.
So x equals 4.
So 4, 1 is another solution.
So 4, 1 would be your fourth solution.
Okay, so it seems like a useful strategy.
Yeah, a useful strategy
is to whenever you're trying to find these.
Yeah.
Is just to plug in 0 for x.
Right.
And then 0 for y.
Exactly. And those usually give you 2 quick solutions.
Oh, right.
Now,
example
4 gives us a few more equations and asks us to find 2 solutions for each.
Okay.
So the first one is 4x plus 3y equals 12.
Okay.
Can you come up with two solutions for that one?
So if we plug in 0 for x, then that gives us 3y equals 12.
Right.
So y equals 4.
Exactly.
So that's one solution.
Yeah.
And then if we plug in 0 for y, then we get 4x equals 12.
Right.
So x equals 3. So
good.
Is another solution.
Perfect. All right. Okay, what's next?
All right. The next equation they give us is 2x plus 5y equals 0.
Okay.
So if we plug in 0 for x, what do we get for y?
We get 5y equals 0.
Right.
Which means y is also 0.
Yeah. So it's a solution. And then if we plug in 0 for y, we also get x equals 0.
We also get x equals 0. So
we've got to pick a different value.
Right. We have to choose a different value to get our second solution.
Okay. So what did they choose?
They chose x equals 1.
Okay.
So if we plug in x equals 1, then we get 2 plus 5y equals 0.
Okay.
Which means 5y equals negative 2.
Yeah.
Which means y equals negative 25.
Okay.
So that gives us another solution, 1, negative 25.
Right.
All right.
Okay, cool. It's kind of interesting that 0, 0 can be a solution.
Yeah, it is interesting. And what that tells us is that the line representing this equation will pass right through the origin on a graph.
Okay, cool.
Okay, so
what about that last equation?
Right, the last equation they give us is 3y plus 4 equals 0.
Okay.
Now, this one looks a little bit different.
Right.
There's no x term explicitly there.
Yeah.
But we learned that we can think of it as 0x plus 3y plus 4 equals 0.
Right.
So in this case, no matter what value we pick for x, what will the value of y be?
So if 0x, it doesn't matter what x is.
It doesn't matter what x is.
3y plus 4 equals 0.
Exactly.
So stays the same.
3y equals negative 4.
Right.
So y equals negative 43.
Right. So it doesn't matter what x is.
It doesn't matter what x is. Y will always be
negative 43.
Negative 43. And the material gives us 0, negative 43, and 1, negative 43.
Right.
As two examples of solutions.
Right.
But notice that the y value is constant.
Yeah.
While the x value
can be anything.
Got it.
That
makes it's like a flat line.
It is on a graph.
Yeah.
Where the height never changes.
Exactly.
Oh, okay, cool.
Yeah.
So I guess I want to sort of bring it back to like to the real world for a second.
Sure.
You know, remember that cricket score of 176 runs?
Yeah, I remember.
You know, and we represented that as x plus y equals 176.
Right.
So think about all the different combinations that the two batsmen
scores for each batsman.
Received, yeah.
Yeah, so one batsman could have scored 50 runs.
Yeah.
The other batsman could have scored 126.
Right.
One could have scored 175, the other just one.
Right.
I mean, there's a huge range of possibilities.
Yeah.
And so this kind of simple real-world scenario really highlights how a single linear equation with two unknowns can have many, many different solutions.
Right.
Yeah.
It really sort of drives the point home.
Yeah, it does. So in the source material, they have some exercises that help you to kind of solidify these ideas.
Okay.
And one of the questions in exercise 4.1 asks you to write a linear equation to represent this statement.
Okay.
The cost of a notebook is twice the cost of a pen.
Okay.
So how would we go about...
Okay, so let's say x is the cost of the notebook.
Yeah, let's say x is the cost of the notebook.
Yeah.
And y is the cost of the pen.
Okay.
So then the equation would be x equals 2y.
Right. Okay.
Right.
Okay.
Or we could rearrange that into that standard form, x plus y plus c equals 0.
Right.
And it would be x minus 2y equals 0.
Okay, got it.
And that's just a very simple example of how these equations can represent real-world relationships.
Stuff. Cool.
Right.
And then exercise 4.2 question 1 asks this kind of fundamental question.
Yeah.
It says, which one of the following options is true and why?
Okay.
For the equation equals 3x plus 5.
Right.
And then it gives you 3 options.
Yeah.
A unique solution.
Okay.
Only 2 solutions or infinitely many solutions.
Yeah. So after our discussion, the answer should be pretty clear.
Yeah.
Yeah. The answer is infinitely many solutions.
Yeah.
And the reason is because for every value of x you choose, you're going to get a unique corresponding value for y.
Right.
And there's no limit
right.
to the number of values of x
exactly.
that you can choose.
Okay, got it.
And then question 3 in exercise 4.2 gives you the equation x minus 2y equals 4.
Okay.
And it asks you to check whether certain ordered pairs, like 0, 2, 0, 3, or 0, so are solutions to the equation.
Right.
And
so that's really just putting into practice.
Yeah, that's putting into practice the definition of a solution.
The definition of a solution, right.
You just plug in those values and see if the equation holds true.
Yeah, exactly.
And it's a valuable exercise in kind of reinforcing what it means for a pair of numbers to satisfy an equation.
Right. Cool. And then finally, there's question 4 in exercise 4.2. Okay. And this is a bit of a different type of question. It says, find the value of k.
Okay.
If x equals 2, y equals 1, is a solution to the equation 2x plus 3y equals k.
Right.
So how do you solve this type of problem?
Well, so since we're given that 2, 1 is a solution, we know that when we plug in x equals 2 and y equals 1 into the equation, it must be true.
Okay.
So we have 2 times 2 plus 3 times 1 equals k.
Okay.
So that means 4 plus 3 equals k.
Right.
So k must equal 7.
Okay, so you can use the fact that you know the solution.
Yeah, you can use that information to figure out an unknown part of the equation itself.
Okay, got it.
Right.
So just to kind of recap our key takeaways here.
Yeah, let's recap.
So a linear equation in 2 variables.
A linear equation in 2 variables.
Has the general form. X plus by plus c equals 0.
X plus by plus c equals 0.
Where a and b cannot both be 0.
Where a and b are not both 0.
Right.
At the same time.
And the really big idea here is that
a
single linear equation in 2 variables.
That a linear equation in 2 variables
does not just have one solution.
Doesn't have just one solution.
That actually
has an infinite number of solutions.
Yeah, infinite number of solutions.
Right.
Okay. Each of those solutions
is represented by an ordered pair.
An ordered pair.
That makes the equation true.
The equation true, okay.
Got it.
And then the material we looked at today concludes by saying that every point on the graph of a linear equation in 2 variables corresponds
to a solution of that equation.
A solution to the equation.
And vice versa, every solution corresponds to a point on the graph.
Corresponds to.